Assalamualaikum and good day everyone. In this video, we're going to learn polymorphism in object-oriented programming. Let's get started. First of all, what is polymorphism? Polymorphism is the ability of an object to take on many forms. The most common use of a polymorphism in OOP occurs when a parent class reference is used to refer to a child class object. Any Java object that can pass more than one is a test is considered to be polymorphic. In Java, all Java objects are polymorphic since any object will pass the is a test for their own type and for the class object. It is important to note that the only possible way to access an object is through a reference variable. A reference variable can be of only one type. Once declared, the type of reference variable cannot be changed. For example, if cat and dog are subclasses of pet, then the following statements are valid, which means that I declare pet my pet, so my pet is a variable, and then I create new dog, and later on I create my pet equal to new cat. Right. Let's look another one. Let's say we define a student roster array which consists of 40 students objects, combining objects from undergraduate student and graduate student classes. In this visualization, we can see that the roster array with the elements referring to the instances of graduate student or undergraduate student classes. So this will be varies until 39 array. Next, let's look at how we can access the specific object of student. For this case, we can use the for loop structure to access the object. Let's say if roster I refers to a graduate student, then the compute course grade method of the graduate student class is executed. So if roster I refers to undergraduate student, then the compute course grade method of undergraduate student class is executed. Next, let's look at the instance of operator. This operator can help us learn the class of an object. The following code counts the number of undergraduate students and is also checked if roster I is instance of undergraduate student, then the undergraduate counter variable will be added. Moving on to abstract superclasses and abstract method. So when we define a superclass, we do not need to create any instances of the superclass. Depending on whether we need to create instances of the superclass, we must define the class differently. We will study examples based on the student superclass that we defined earlier. So coming back to the definition of abstract class, so an abstract class is a class defined with the modifier abstract, or that contains an abstract method, or that does not provide an implementation of an inherited abstract method. An abstract method is a method with the keyword abstract and it ends with a semicolon instead of a method body, so it doesn't have any method body. So private methods and static methods may not be declared abstract. And no instances can be created from an abstract class. So that is the definition and also rules of abstract class. Next, let's look how we can define classes with polymorphism. So let's say we have a case study. Suppose we want to implement a class roster that contains both undergraduate and graduate students. So each student record will contain his or her name, 3 test scores, and the final course grade. So they also have a formula for determining the course grade, which is a different kind of formula for graduate students and undergraduate students. So for case number 1, student must be undergraduate or graduate student. So if a student must be either an undergraduate or a graduate student, we only need instances of undergraduate student or graduate student. Therefore, we must define the student class as an abstract class so that no instances may be created of it. So there will be no object of student, but there will be only object of undergraduate student and graduate student. So this is the virtual representation of case number 1. Student as the parent class, and also we declare as an abstract, and then we also have one abstract method, compute course grade, which is shareable by undergraduate and graduate class. So both undergraduate and graduate is a child class of student. So we need to declare class undergraduate extends student, class graduate extend students. Next, let's look at case 2. Student does not have to be undergraduate or graduate. So in this case, we may design the student class in one of two ways. First, we can make the student class instanceable, meaning that we can create student object. Or we can leave the student class abstract and add a third subclasses, which is other student. So this is to handle a student who does not fall into undergraduate student or graduate student categories. So let's look at the visualization of this. So this could be another solution for case 2. So we declare abstract class student and abstract void compute course grade. So you'll have 3 subclasses: undergraduate extend student, graduate extend student, and other student extend student. Notice that you have compute course grade in each of the subclasses. Next, let's look to interface. So what is interface? So basically, Java has only one single inheritance. So which means that a child class inherits from only one parent class. Mostly in object-oriented programming, this is all what you need. But sometimes multiple inheritance would be convenient. So interface gives Java some of the advantage of multiple inheritance without the disadvantage. So in Java, an interface is used to express an aspect of a class other than what it inherits from its parent. So interface is a collection of constant and method declaration. The method declaration do not include any implementation. So this is the syntax of interface. How to use it? Alright, let's look at it. Objects can be constructed from a class that implements an interface. So we can declare a class definition that implements an interface like this. Class some class extends some parent implements interface name. So a class always extends just one parent but may implement several interface. Now let's look at an example of interface definition. So a method in an interface cannot be made private. A method and interface is public by default. So in this example, we can see that method B is public even though it does not say so, meaning that we didn't define the public method B here as a public method. So this is a syntax to define an interface. So we have interface, my interface, and then this is all the declaration of constant, and this is the method declaration. So it doesn't have any body implementation. So the body implementation will be defined in the class. Alright, let's look at implementing the interface. So a class definition must always extend one parent, but it can implement 0 or more interfaces. So in this case, we can have more than one interface in a particular class. So public class big class extends parent, implement interface A, interface B, and interface C. Whereas this one, it only implement one interface, interface A. Alright, let's look some example. So in this example, the store sells goods, each of which has the attribute description and price. The goods are either food, toy, and book. So which means that each of the subclasses will have their attribute. So food have an attribute calories, toy have the attribute minimum age and book have the attribute author. So the problem says here, toys and books are taxable, but food is not. So we want to have the concept taxable as a separate concept, but not part of the concept of good. So a taxable item has a tax rate of 6% and it has a method to calculate tax in the interface of taxable. So in this case, right, what we need to do, so we do know that the goods will be the parent and the rest will be the subclasses, food, toy and book, except taxable item, okay, it will be an interface that only applied for toy and book. Alright, just now we have looked into the example problem of having a polymorphism with an interface. So let's discuss now what is inheritance versus interface. So the Java interface is used to share common behavior, which is among the instances of different classes, whereas inheritance is used to share common code among the instances of the related classes. In your program design, remember to use the Java interface for you to share the common behavior. Use inheritance to share common code. Let's say if an entity A is a specialized form of another entity B, then model them by using inheritance. Declare A as a subclass of B. So I think that's all for now. Please read chapter 1 in your future platform. Thank you.